Check, check. Yo. Check, check. All right. What time is it? Hello? Okay. I'm just like still trying to make sure everything works. Alright, I'm just gonna do the same thing I did yesterday and just go through drawing the circle again to start. I feel like I could always benefit from practicing this. It was like ambitious to try and do this 2 days in a row because like I feel like my brain is still a little fried from doing it yesterday. But maybe that's the best time to learn, you know what I mean? Right. Oh, and I made this to make the notes bigger. Beautiful. So it's quadrant 1? Or everything is positive? Quadrant 2? Where sine function is positive, negative x, positive x. Because I do music, I'm always tempted to write 3 is like a minor 3, which is lowercase. But just like in my brain, it's anyway. It's like music theory stuff. And 4. And quadrant 3, the tangent function is positive. And both x and y are negative. X is positive, y is negative, and quadrant 4. Alright, easiest thing to start with is degrees. 0 degrees. There's 3 sections in each quadrant, and 90 degrees. 3 sections in each quadrant. Pi is 180 degrees. 3 sections in each quadrant. You just start with 0, add 90, add 180, it's halfway there, 270, and then 360 degrees. All of our common angles. For the common angles, we got 30 degree angles and 45 degree angles, right? So start with 45, half of 90 degrees. $90 plus 45 degrees is 135. 180 degrees plus 45 is 225. Plus 45 is 270. Plus 45 is 300 degrees. Then we do the 30 degrees. Alright, that's a third. That's the easy part. Go ahead and knock that out. Beautiful. 30 degrees is 6 to the pi. 45 degrees is 5 or 4. So we'll start with 45 degrees just to fill these one. Fill the halfways out, right? The segments, halfway segment. So pi over 4, 2 pi over 4 is 90 degrees, is pi over 2. 3 pi over 4 is 135 degrees. 4 pi over 4 is just pi. That's 180 degrees. 5 pi over 4 is 225 degrees. 6 pi over 4 is the same as 3 pi over 2. And that's 270 degrees. 7 pi over 4 is 315 degrees. And 8 pi over 4 is 2 pi. Then we'll do the sixths. Sixths. So yeah, pi over 6 is 30 degrees. 2 pi over 6 is just the same as pi over 3. Pi over 6, 3 pi over 6 is half pi. 1, 2, 3. 4 pi over 6 is 2 pi over 3. Partition wizard. One, 2, 3, 4. 5 pi over 6 is 150 degrees. 6 pi over 6 is the same as pi. 180 degrees. 6 pi over 6. 7 pi over 6 is 210 degrees. 8 pi over 6 is 4 pi over 3 for 240 degrees. 9 pi over 6 is 270 degrees. 10 pi over 6 is the same as 5 pi over 3. That's 300 degrees. 11 pi over 6 is 330 degrees. And and 12 pi over 6 is 2 pi. So that's, yeah, 2/3 of the way. Easy. Way easier than yesterday, you know. Now it's fresh on the mind, right? Right. Now, I remember from yesterday, well, first, before that, just do the extremes. The extremes being like the largest x values and largest y values, which are 1, right? So 90 degrees is 0 on the x-axis and 1 on the y-axis. The same thing for 270 degrees, except for y is negative, x is 0. So 0, comma, negative 1. For 180 degrees, negative 1x, 0y. 0 degrees, it's 1x, 0y. Cool. Anyway, so I know that the 45-degree angles are the next to the easiest, right? It's like they're the square root of 2 over 2 for both angles, for both lengths from the origin. Let's go ahead and fill those in. First quadrant, both are positive. Second quadrant, x is negative. Third quadrant, both are negative. So this made it a lot easier for me, having one day where I have to do it without checking a reference, and then just using whatever I had stored in my brain, and then today trying to do the same thing again. Memory is a lot easier to remember. Now that I've like forced myself to try and remember it one time, you know. Alright, and then the 30-degree angles. I know the other values are square root of 3 over 2 and 1/2, but I can't remember which order they go in, so I'm just gonna check with the calculator real quick. For 30 degrees, sine 30. So the y value of 30 degrees is 1/2. And the x value is square root of 3 over 2. And then I just do the opposite for 60. That would make 1/2 as the x value, and square root of 3 over 2 as the y value. And I'll just double check that real quick. But I'm feeling very confident. Alright, sweet. It has been double checked. It checks out. Then you just take the same thing, flip it across the y-axis, right? To this side. Just making sure to add the negative in the right place, which in the second quadrant, x is negative, y is positive. So for 120 degrees, x is negative 1/2. Y is square root of 3 over 2. 150 degrees is negative square root of 3 over 2. 1/2. 210 degrees. For this, we can just take this and like mirror it over the x-axis. And it just works that way because this is the same distance from the origin as this is. Right? You're gonna have to mirror it, flip it over, right? And just make sure to add negative and positive in the right place. Because see, you can sort of see it here, right? Like this angle, this dot is 1/2 length. It's, I guess, this is the same length as this, right? Or it would be if I could draw, or it should be. Theoretically it is, right? So, yeah. Anyway. Negative square root of 3 over 2. Negative 1/2. Negative square root of 3 over 2. On the side. Wall right here. Positive x. Square root of 2 y. And then for 330 degrees, square root of 3 over 2. Negative 1/2. Sweet. Right, glad to get that one out of the way. Jeez. It kind of takes forever, right? But it's worth it. I hate to draw it out for every problem. Okay, let's get on to the good stuff. Made it through 29 questions. A long review. What I was saying earlier today, it's only 20 questions on the test, or 20 to 30, somewhere in that range, right? So like, that feels reasonable for 2 hours, right? Especially with like some of these problems, like those angular speed, linear speed. That shit's crazy. Alright, let's just get in there. I'm gonna start at the end, because it just feels good. No, I don't want to start here. Ouch. Just look at that, my head started hurting. Alright, let's start here. The domain of the tangent function is domain meaning all x values, right? I guess I remember looking at the tangent function, it's sort of as like this shape, right? it's like goes through the origin. I'm pretty sure. And then it has like right here. And then I think this is pi over 2. Negative and positive. So the first asymptote is the regular one. I'm pretty sure it's right. But there's also a way to check what the asymptotes are. And yeah, the best way to check the asymptotes is just try and put them in the function and see if they work. So it doesn't seem like pi over 2 is correct. Unless I need to be in radians mode. Yep, I need to be in radians mode. So yeah, it looks like pi over 2 is undefined. And then we can also check 0. And if I put in 0 and it's 0, then I think I drew the graph right. It's 0. How about that? What's 1? Some crazy number? Is that the square root of 3 over 2? No, it's the square root of 2 over 2, right? Nope. Is it 2 times the square root? 3 times the square root? Square root of 3 over 2? 3 times the square root? I have no idea what it is. Either way, we figured out this is correct, so yeah, 2 pi is 0. So that's where it starts over, is at 0. Or, that's where it starts over is at 2 pi. So it looks like, yeah, all real numbers except odd integer multiples of my pal here, pi over 2. This is not correct because this is just pi, right? And we kind of wait. Is that one for cotangent? No, yeah, we're good. Okay, pretty sure this is right. All real numbers, nope. We have asymptotes in the tangent function. All real numbers greater than or equal to 1. Or less than or equal to -1. That's like... That sounds like it'd be for secant or cosecant. No. That's the range of something else. Not this. It's E. Gotta be. Excellent. We're gonna talk about it. This thing is longer than the question itself. It's crazy. Alright. I swear, dude. Pearson is like the cocaine of like, dude, they were on so much drugs when they made this. It's crazy. And they made it and then they just like never looked at it again. They made it all like in one night and then just never opened they put it up there and they're like, I'm not I don't want to see that again. It's gonna hurt my brain. Which of the following is not in range of the sine function? I guess it would be anything above 1, right? Is that what they're asking for? Because the range is the y values, right? And we got 1 here, got -1 here. It's going like, it's like the regular sine function without any variations to it would just exclude everything outside of -1 and 1, which would make our answer the D. Let's see if that's right. Cool. 2 for 2, baby. We're on a roll. Use the fact. Is that a fact? You sure? Alright, use the fact that the trigonometric functions are periodic. Oh, hold on, I gotta change the fact. But like, these notes are too big. Maybe I can just. I really need to cut like a website that's more customizable. You know what I mean? We'll try that for now. See how that feels. Alright. Okay. Tan 585 degrees. No, do not use get out of here. Can't use calculator. Alright. Use the calculator. Periodic to find the exact value of the given expression. Okay, so I just when I see periodic, I'm just like, oh, we take off 180 degrees several times, right? Because the period of the tangent function and the cotangent function is just pi. Tangent and cotangent are exceptions, right? Because all four of the other functions, their period is 2 pi, so you can always take off 2 pi or 360 degrees from whatever this value is to get it within the range of the unit circle. Cotangent and tangent are only 1 pi because, right, like you're gonna get the same value as your answer for those two, whether you do it in quadrant 1 or 3, right? And the same for 2 and 4. So this is like, it's starting over. All the values on the bottom are similar to the values on the top. Anyway, that's a long-winded way to say I'm going to use the calculator just for subtraction because I don't know. You know what? No, let's do it the right way. This is extra credit. I'm doing it. I'm doing it for free. I don't need to win all the time. 585 minus 180 times 3. So I think that leaves us with 45 degrees. Pretty sure. Which would make the tangent function at 45 degrees is that y value, square root of 2 over 2, divided by x value, square root of 2 over 2. And see, we know the period. Here's the proof for if the here's the proof for the period being just pi, right? Because if we were to do the same thing in the third quadrant, say it was, if the answer was 225 degrees instead of 45, which it might be, who knows? We get negative 2 over 2, sorry. Negative the square root of 2 over 2 divided by negative square root of 2 over 2. The negatives just cancel each other out, so we're like left with this anyway. Anyway, I'll read this. So now we have square root of 2 over 2 over square root of 2 over 2, which is, I'm pretty sure it's just 1. Seems like it'd be 1, right? Beautiful. 3 for 3. We're on a roll. I'm not gonna die now. Alright. Use the fact that the trigonometric. I'll never be able to say this word. Trigonometric. Functions are periodic. To find the exact value. Oh, it's the same question, just with a different. Alright, that's fine. So we're just trying to get this value lower. Yeah, 25 pi over 3. Jesus. So, I think the easiest way to do this in your head is just like take 2 pi and just convert it to having the least common denominator of the question, right? So 2 pi times 3 is 6 pi over 3. And we're just gonna like subtract 6 pi over 3 from this guy, the question itself, until we're left with something smaller than 6 pi over 3. So I can sort of just see that 6 times 4 is 24. So we can do that, and it'll just give us pi over 3. And yeah. How many times is that? That's 4 times. So what we got here is 4 rotations, and then a little bit more, pi over 3 more. 4 rotations plus 60 degrees. I just know that because of how many times we can put 2 pi into this thing. Number 2 big, just keep subtracting 2 pi. So it should be pi over 3. It's a sine function. For pi over 3, the y value is the square root of 3 over 2. So let's see if I did that right. Excellent. That was good, man. That was good. That was so fun. It feels like I'm about to almost understand something, and then like here in a minute they're gonna hit me with a curveball, and my entire understanding was shaken from the ground up. Or at least that's how it's been so far. Or maybe I've hit that last one for this unit, at least for this chapter. We'll see. Like, I feel like when we get to the secant and cosecant graphing shit, like, there's still something in that I don't understand. I've been trying to find it before it finds me. You know, there's just one little missing piece. I don't know what it is, but I know it's there. Anyway, name a quadrant in which the angle 0 lies. So for this, all are positive in the quadrant 1. The signs are positive in quadrant 2. Signs and the reciprocal. So that would be cosecant. Third quadrant, cotangent and tangent positive. In the fourth quadrant, cosine and secant are positive. this question, it looks like they have cosine is positive and tan is negative. So that means we're definitely in quadrant 4, right? We're about to find out. What? Oh, I just can't read. I even wrote it down. Tangent's greater than 0, so it's gotta be quadrant 1, right? Thank God. Ugh. Okay, and this one, instead of distracting myself with drawing it all out, I'm just gonna say sine is less than 0. I mean sine is negative. Cotangent's greater than, so this one's quadrant 4, please. One time. What? Oh, I can't. Dude, it's like reading is so hard. Cotangent's greater than 0. Holy shit. They just all sort of look very similar, except for tangent. Tangent's very easy to see. Sine of theta and cosine of theta are given. Find the exact value of each of the 4 remaining trigonometric functions. These are fun. I always enjoy these. So we got what? Sine equals 3 over 5. Cosine equals 4 over 5. Now does this just mean that x is -4? Get that out of here. Y is 3 and R is 5. I feel like that's what it means, but there's probably a way to check. Anyway, that would make tangent. Yeah, it has to be that, right? Tangent would be negative 4? 3 over 4. Cotangent. Dude, I'm actually kind of sad because I just realized like all of this is going to be erased when I start entering these things in. That's okay. There's gotta be a way to not do that, but it's alright. Cotangent would be -4 over 3. And then cosecant 5 over 3. And secant 4 over 3. No. 5 over 4. Gorgeous. Like a glove. It's perfect. Maybe I can try this. No, I can't like... I guess I can't edit this page without closing this out. That's right. I think I can remember. So, this one was 5 over 3, right? Secant. The inverse of cosine. -5. Tangent is y over x. That's -3 over 4. Nice. And then cotangent is just the inverse of that. Beautiful. And that probably works perfectly with the Pythagorean theorem. Don't even worry about it. Don't even gotta check. Just trust this, bro. No, it works. Actually, that's like one that I remember. It's like, oh, that is so nice. That works perfectly. Find the exact value of each of the remaining trigonometric functions of theta. Sine theta equals 3/4. Cotangent theta is less than 0. Okay, so we just gotta remember we're in the second quadrant because yeah, because cotangent. Oh, dude, I don't know. We could be. Yeah, it's gotta be in the second. It's gotta be in the second quadrant because sine is positive, but cotangent's not. If cotangent was also positive, we would be in the first quadrant. So that's the important thing to remember here. Which means cosine also has to be negative. I'm pretty sure. Pretty sure that's how it works. We'll find out the hard way. So, I like to do this is just like write out all of them so that you don't miss anything. Because it can get confusing with like all this stuff going on, man. Honest, in my opinion. So we got sine is equal to 3/4. Cotangent. Oh, okay. Next thing we'll do is do reciprocal CSC. It means it has to be 4/3. Okay. So we got those two. Next is cosine, which we know has to have the same denominator as the sine. But the numerator, we don't know. And the numerator is x. Secant, it's going to be 4/x. Tangent is x/3. No. X on the bottom. 3/x. And then cosecant is x/3. Now I'm going to ignore the fact that this is the exact same question as the last problem. Because I can already tell, just because of the problem we just did, this is the x is 5, right? Spoiler, but it's true. It's just, we just did this exact ratio in question 36. So like, there's literally, like, it's very easy to tell. But we'll just do the Pythagorean theorem for fun, you know. Just to see if I'm like delusional. So, gotta be. Because, dude, I might be wrong here. Who knows? I've been wrong before. Okay, so 4 is our r. Is equal to. So it'll be 16 squared. Or 4 squared is 16. Would be the same as 3 squared. Would be 9 plus x. So actually, I was wrong. I think it's the square root of 5. I've confused myself. Huh? 7. Square root of 7. Right? I'm gonna check with the calculator. So the answer should be 17. Let's see. I think I just like confused myself. Hold on, I'm gonna use the restroom. I'll be right back. Alright, dude. I got some sort of allergies. I never have allergies. So. Anyway. It's gotta be the square root of 7. I'm just gonna send it. Let's see what happens. So that would make cosine negative square root of 7 over 4. Nice. So if that's true, then we already know the rest of it. Tangent. Y is on top is 4 over square root of 7, I think. But we have to rationalize. So just take this, take it, put it on top, and 7 down there, and rationalize. Huh? Oh. This is tangent. I did it backwards. So this is square root of 7 over 3. Or 3. Yeah, but it's negative. Please? Thank God. Okay. Tangent. Except for I keep trying to use R, but you don't need R. Nice. CSC 4 over 3. This is positive because sine is positive. SEC is going to be cosine put upside down. So this is actually CSC, I think. Let's see. No. Yeah? Yeah. This 4 is on top. Rationalize. Nice. Use the even-odd properties. Use the even-odd properties of the trigonometric functions to find the exact value of the given expression. Do not use a calculator. Okay. I'm pretty sure this is just saying like because we have negative 30 degrees here, right? We can just take the negative, put it outside, and just do the unit circle thing for 30 degrees. Just because it's sine, which I believe is 1/2. And see how that works. Nice. Easy. But cotangent, same thing. You can do the even odd properties thing. So pi over 6 is actually 1 over the square root of 3. So this is square root of 3. And then we just put the negative sign in front of it. Huh? Okay, maybe I'm wrong. Cotangent? Oh, I didn't put a negative at all. Even though I said I was going to. That's what you get for lying. What? How? Oh, weird. I said earlier, like tangents is easy to read. When I see cotangent, I'm like, oh, the tangent. It's easy. So I just do the equation for tangent every time, regardless of what this says. It's not even like it shares one letter, and it's at the very back. It's crazy. Okay, so the real answer, I was just testing you. Okay, so cancel the 2's. We got square root of 3. But it's negative because of the even odd properties of trigonometric functions. I hope. Nice. This is also like, it's nice doing this review because it's telling me the right answer, but like it's kind of freaking me out because of like how many mistakes that I make on like flipping x and y and then changing things from negative to positive, right? Like so often. It hurts. It's so painful. Alright. Amplitude? The sine function? Absolute value of A? Good. W is 9/7, which makes W. Omega? So that makes 2 pi over 9. I gotta like simplify that a little bit, I think. over 9? Is that how that works? Yeah, that's how it works. I don't know why it works that way, I just know how to do it. That's nice. Graph the function y equals cosine x. Show at least 2 cycles. Use the graph to determine the domain and range of the function. Okay, so I just need to add the amplitude and make sure it's a cosine. Not 51. Looks good to me. Looks good to me. Cool. Use the graph to determine the domain. Domain is all real numbers, right? I don't know how to type that. Oh, I do. Use the graph to determine the range of y equals 5 cosine x. Range is -5 to +5. Right? Huh? Oh, I have to put the inclusion bracket. Gotta be it, right? I think the key is to like you draw something like this. It's like you can't tell if the if it's supposed to be curved or like a square in the end. Just kind of put a little bit of both, right? I'm totally joking, because that might work for a grade, but like grades don't get you anywhere in life. Only knowledge. Only knowledge. Probably. I don't fucking know. I haven't got anywhere. But you know, somebody had to invent something, and they probably used the right brackets on their schematic. And they submitted it to the patent office. That's how that works. I'm just guessing. Okay. This is period of 2 pi over 3. Right? That's all we have to do? Dude. Like, having to type this in over and over again. It feels like it, I don't know. There's gotta be a better. I'm just not gonna. It just feels like insulting to have to type this out every single time. It's one thing to write it, but like, so many clicks. Yeah. Although, like, that bump of serotonin that I get in reward is still worth it, I think. Sorry, dopamine. Use the graph to determine the range of y equals 3x. Oh, I don't know why that like locked me out. Alright. Range? That's whatever we just did, right? Okay, that's 0. Say 1 to 1. I'll use the bracket this time. Beautiful. We're tearing through it, man. I think we're already 12 questions in an hour. Graph the function of y equals. So that's like another. This one, they're like, ooh, we're mixing up. We're giving you amplitude and the period modification. Sine wave. Amplitude 6. Period 12 pi. Because when you 1/6 something and you divide by decimal, it's really the same as multiplying, right? I really like that trick they showed us where it's just like, instead of dividing, man, you just put the denominator as the numerator and multiply it. Like, dude, that's exactly how it works, and I've never thought about it that way. That's how I've always done it in my head. It's just like, I just didn't think of it that way, right? Oh, what? Oh no. Oh no. Did I just like have a stroke or something? Dude, this thing is like impossible to see. I hate it so much. I didn't change the amplitude somehow. Use the graph to determine the domain. Y equals 6 sine. The same question that I've just been working on. It's not new just because it just appeared. Oh man. Right, domain. Same thing. I've been typing in for several questions. You even need to ask. The range should be 6 to 6, right? But with brackets, because it includes. You can't include infinity on your graph. Think I'm wrong? Go ahead and try. Try drawing a graph that shows infinity. That's how I remember this thing anyway. Why you use like the do not include brackets on infinity, because it's like, you know, we don't actually know because we've never seen the graph of infinity. Which is, it's like kind of funny in my head, you know? It's like, yes, but like, we're not sure yet. So, we'll get back to you. We'll let you know when we figure it out. Right? I like it. I think it's fun. Alright. So we got a period modification. We got, it's going to be flipped vertically. Hello. I saw this pop up in the corner. Good evening. Are you from my class, or are you like a stranger that enjoys Precalculus? Either way, welcome. I just got started about an hour ago, and I've just been blowing through this thing. Show the unit circle. Yeah. Currently we're on the graphing sine and cosine part of the test, right? Which, you know, right now it's like asking me to find what makes this different than the original cosine function. Alright, so the period is pi over 5, which is 2 times pi. No. Yeah, that's right. Why can't I write in this spot? Amplitude. And then it's a reflection. About the x. It's gotta be right, yeah? Excellent. Domain. It is still all real numbers. Really not only talking. That's gonna come in handy, I think. The range is I guess they want me to write. Yeah, that's what it looks like. Graph the following function. Show at least 2 cycles. Use the graph to determine the domain and range. This one seems like it's maybe easier than the last one. But this one's the vertical shift. I think if it wasn't, then the +1 would be in parentheses, right? But we'll see. We're gonna find out the hard way. I'm about to fuck around and find out. 3? No. That's not amplitude, is it? No, it is. It is. It is. Vertical shift +1. No reflection. Good to go. Domain. It's still all real numbers. Hotkey. Back left. Nice. Or is that /? No, it's backslash. I don't really know. Three. Alright, use graph to determine the range. The range is, looks like it's just -2 + 4. Alright. Graph the following function. I don't have to read it every time. Sine function again. I feel like there's a lot of questions on this where it's like kinda asking the same thing over and over again. 2 pi over pi over 2. So you take the pi out and then multiply by 2. Vertical shift -2. And we're there. That's gotta be it, right? Fantastic. Pi to insert pi's in. Wait, did I not just do that? Oh, continue. Gotta continue and continuing. It's like when the GPS gives you continue straight for 13 miles. It's like, yeah, I was gonna do that. I was gonna do that until you told me the next thing to do. Use a graph to determine the domain of y. Use a graph. Graph following. Show. Okay. Domain of cos of sine. Domain is still all real numbers. If you're just joining us, calculus short for calculator. I'm just using slang, guys. Range is -6 +3. What? Is that not 6? That's 7. This is getting a little too creative for my taste. This is like some abstract art. I didn't take an art appreciation class yet, so I can't really appreciate it. Alright. This one messes with me, man. Because I think I just have to do something with that 5 at the beginning, and I'm not really sure. I think it's just supposed to be like a 5 up vertical shift, right? And then the midline would just be there, and then it's a reflection from that. Let's try. Let's see if that works. Amplitude is 2. Period is 2 pi over 4, which is just pi over 2. Vertical shift is +5, and then there's a reflection. Is there? Yeah. Oh, okay. That's what everyone has been talking about in class. About this thing where like if you do the reflection last, it ruins everything. That's gotta be it, right? Nice work. All right. Alright, don't worry, I'm back. Everything's fine. I just drank a lot of water and coffee, so you know, gotta keep that. I don't know. I'm gonna stop before I ruin it. Before I ruin the vibe. All right, domain. Zoom in on this. That's 3. Oh wait, domain is just all real numbers again. It's fine. The range is what I was looking at. That's 3 and 7. Bracket. 3. Don't need a negative sign. 7. Bracket. Beautiful. Someone told me they were listening to this while they drive, right? So I'm trying to make it a little more audio friendly. So I'm just gonna get in the good habit of typing or saying literally everything that I do. I'm not like a very extroverted person at all. I'm very introverted, but it's very easy talking at my computer screen, you know? It doesn't feel like a intimidating social interaction. It's like, oh, this is all just like ones and zeros happening in front of my face. And my voice that you're hearing right now is just ones and zeros. It's like, this is literally what you're experiencing right now is like you're listening and viewing just like etchings on a solid state drive in one of YouTube's like or Google's server farms somewhere in like the suburbs of Illinois, you know? Maybe. But somewhere for sure, you know? And that's basically like the physical copy of this is like being read to you over 5G from like etchings on a solid state drive in a server farm. I think it's actually beautiful. I think it's magical. It's like you were listening to Silicon by Zach. Alright. I'm done. I'm like in the final stretch. I'm distracting myself because I'm scared of that last question that I looked at earlier. It's terrifying. Look at all that. I can't. I'm not ready. But it's inevitable. Type the equation in form. Find an equation for the graph shown to the right. Well, if we look at this graph, what do we got? The amplitude is 4. Right off the bat. You can see that. I was watching our professor do this in class today. I think this is a really good approach to doing this sort of problem, right? It's just, or any problem, even if you have the equation and you're doing the graph, I think the best approach is just list all of the factors that you're aware of, right? So A is 4. That's our amplitude. We can see that it's probably a cosine because it does not go through the orange. So cosine. It could be a sine as well. Could it? Yeah, it could be a sine if we do a phase shift. But anyway, it looks like our period is 6. Because period is how long it takes to start over, and it looks like it's 3, 6. So, if it was a sine function, it would have the phase shift of plus minus 3. I think that's how that works. So I'm going to try and write it as a sine function just for fun. For fun and magic. No, because the phase shift would not be 3. Because if we did that, that would just give us the inverse cosine. Not the inverse, the negative cosine function, right? So if we did a phase shift and it was a sine function, it would be plus minus 1.5, which is, I think that's 3 over 2. that would be, if we're doing sine, that'd be y equals 4 sine. Yeah. In the parentheses, we need a 2 here, right? No, because we need a period of 6. So we would need like, to get period, we would need let's do omega 2 pi. So we need something times 2 pi gives us 6. So is that 3 pi times 2 pi? No. That's pi over 3 times 2 pi. Alright. Oh yeah, okay. I think I just said times, but you don't need to say times. Let's see it. 2 pi divided by pi over 3 equals 6. Okay, so that's phase shift, right? Is 2 pi over omega. So now we need to find what gives us phase shift of 3 over 2 using pi over 3 as our omega. So we need, what is this equation? It's pi over 3 times blank equals, I want to put F for fun. F is for friends who do stuff together. Alright. Stop. Alright. Gives us 3 halves. So why is that? Oh yeah, it's because this is where our phase shift is. So that would be 1. Over 2 pi? Is that right? That would mean 1 over 2 pi, 1/2 pi. 1 over 2 pi. Okay. Divided by pi over 3 should give us 1.5. Please? Nope. Oh, very close. Very close. Somehow I have not eliminated the pi. Reverse engineering fractions is hard, brother. Maybe it's 2 over pi. No. What am I not accounting for? Because this has to be pi over 3. Wait, I guess I could just find the value by doing pi over 3 times 3 over 2. And then this as a fraction. What? Oh, whoops. But it won't show me as a fraction. How about 1? Oh, maybe pi is supposed to go on top here. No, I already tried that. Is it just 2 pi? No. 2 over pi. No, pi over 2? Is that it? Yeah. So I think that makes the entire this is getting a little harebrained, but I think that makes the entire equation 4 sine pi over 3 x plus or minus, let's do minus pi over 3, and it could be plus, I think. I mean, sorry, pi over 2. Let's see if they'll accept that answer. Because I think it could be that. And if they don't accept it, I'm just going to write the cosine because it's way, way, way easier. But it was still like a fun thought experiment. And I don't regret the time that I wasted on it. I feel like at some point it's going to come in handy later. Just for fun, I'm going to double check it. I want to double check it before I hit enter, because I want to be right so bad. Okay, so this is the period, right? 6. 6 is the period, right? 1, 3. 3, 6. That's the period. Yeah? That's fine. This is W. So we should also divided by pi over 3 give us 1.5, which is the phase shift, right? Because instead of starting here, it has to be negative though, right? Does it? Or does it have to be? So I think I have to put plus in the parentheses. So that we get a negative phase shift backwards. Because we want this to be the origin. Alright, let's see it. Although your answer is equal to the correct answer, it is not in the correct form. Oh. What? If there are no special instructions, make sure your answer is fully simplified. I don't know how much more simplified you can get than this. Is it only the correct form if I write in cosine? Because I feel like, or is it just like actually a more simplified version just to write the cosine version? So I'm not sure, and either way, I'm happy that I got the right answer the wrong way. But it's a little bit lame, you know what I mean? So is it 4 cosine, what is it? The period is 6. With no phase shift. So 2 pi over pi over 3. Nice work. I'm disappointed, I'm not gonna lie. I thought my answer was cooler. But I understand why they're saying like that's not the most simplified form. It's like if you're gonna... It's essentially like if you're doing... you could take the answer that I gave and simplify it further by using identities. I think is what they're trying to tell me right now, which is true. It's like, yep, that's less numbers. You're damn right. Okay. Final stretch. We got what? 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 14 more questions. Very close. And I haven't had to like similar question one of these, which is great. But I feel like most of it's been pretty easy so far. And some of them I was like very close to losing the contest. And you know, going back to the factory. Type the equation in form y equals a. Okay. So this one goes to the origin, so the simplest version is the sine function. But this one is a negative sine function because it's gone upside down with an amplitude of 2. Because 2 is the max, 2 is the minimum. Got the parenthesis there. And we're gonna have, looks like a period of, we got what, pi over 2, wait, pi over 4, pi over 2. I don't know how to subdivide 2 pi over 3 into fourths. I'm gonna look at the unit circle. There's gotta be a way. I definitely can't do it in my head. Okay. Wait. I'm sorry. I have not looked at the screen in a while. I guess it's pretty hard to see the graph. I'm gonna minimize the notes a little bit. It is so hard to like fit everything on the screen properly. See if I put it there, it covers the answers. Maybe here. There's like almost never anything there. Maybe I like put it sideways. For now at least. Yeah. Something like that. Oh, here we go. Put the camera here. Let's hit this back. Perfect. Now this is only covering the question numbers. That works for me. Be a little smaller. Okay. Thank you. Thank you for bearing with me. Okay, so 2 pi over 3 is 120 degrees. 120 degrees divided by 4. Is that what we're doing? $30. So each interval is pi over 6. Yeah, pi over 6. Pi over 3. Pi over 2. 2 pi over 3. Those numbers in my head don't sound like they would do that, but we're just gonna roll with it. So our period is 30, 60, 90, 120, 150, which is 5 pi over 6. It's our period. But we have to reverse engineer that to make it so I think that's 5 pi over 6 divided by 2 pi, we get this our answer. Of course it's, what is it, 5 over 12? I feel like that's not right. Or no, that's not the most simplified version because I did the X shift or the X flip, X mirror. So the most simplified version is I just move it 30 degrees. No wait. I'm finding the period. I'm not moving anything. So yeah, 30, 60, 60, 90, 120, 150, 5, 5, or 6 is the period. Okay. You know what? I think what this is trying to show us is... No, that's harder, right? Okay, the real equation, right, is 2 pi divided by blank gives us 5, 5, or 6. I mean, let's just try 5 12. I think I did the math right. Let's see if I did it right. Nope. Wait. Yeah. Nope. I mean, I should just be able to plug this in here. Okay, total of 5. Dude, I really cannot believe that they have had calculators that can do turn decimals into fractions this whole time. Like, bro, it kills me. And the calculator I have probably does it too. Huh? Period equals. I'm sorry. How's that wrong? Looks like the right. Looks like the same answer to me. W should be total of 5. Amplitude should be 2. Am I just not doing the period right? One. 30, 60, 90, 120. God damn it. So B, I'm trying to find 2 pi over 3. So the answer is just these 3, not this crazy fraction I got. But with pure sense, you never know. Sometimes they'll give you that crazy fraction, and you just gotta be like, oh, well, that looks right. I guess square root of 57 over 698 is, yeah, that's the answer. It's just sometimes it's how it works out. Sometimes that's how math questions go, but not in this case. In this case, it's something else. All right, this is where I'm gonna start getting tripped up because the tangent, secant, cosecant functions are the ones I'm least familiar with. Okay. So the tangent function we have asymptotes at pi over 2 because the period is pi. So to start over on pi over 2. And the amplitude doesn't really mean anything. It's like a vertical stretch, but that doesn't change much here. So we got pi. I guess they're trying to say it's right here. So 1, 2, 3, 4. So each of these is pi over 2, which makes that pi over 2 pi. So I think it's D. That's like if it was tan of negative x, I guess. This is trying to make us think that this is a stretch. Use the graph to determine the domain. It's pi over 2 is the asymptotes. Is it? It is. It's got it, right. Nice. So I think these other two answers are, like, let's say if they put tan 2x, it would be this one. If they put tan half x, it would be this one. Pretty sure. Range is, I think it's infinity, right? Yeah. Nice. Cotangent function is the reverse. So it's not this one. I'm just gonna go with it's definitely this one, very clearly, obviously already, because essentially they've been telling us the amplitude's fake, right? It's definitely not those two. There's no negative signs. This one is still once again trying to trick us and make us think that this 9 here is some sort of stretch, but it's not. It's a stretch up, which, like, I guess because it doesn't land on any real numbers or any whole numbers, that we shouldn't care about it. But I also get the feeling that, like, in calculus and like further maths, this is going to be something that's very important, this 9 here. But like precalculus is teaching us, like, it doesn't really matter, you know, as long as you kind of generally figure out where it's supposed to be, you know. You can just ignore it for now. I feel like this is what this line of questioning is teaching us, right? But we'll see. I'm speculating. I've never taken anything beyond this math, right? But like, this is a trick question. I don't appreciate it. And then, like, also, I feel like at some point in the next 3 math classes I'm going to take, like, this 9 is going to be, like, important to think about, not just like brush over. But you know, we'll get there when we come to it. I think, you know, in class, our professor was talking about how to show that on the graph. When he first taught us this, he taught us a way to show the vertical stretch on tangent, secant, cosecant, and cotangent functions. But you know, I can learn that in my free time too. You know, it doesn't seem like we're going to test it on that specifically, which is nice because I feel like this chapter has been like very dense. You know, use the graph to determine the domain of 9 cotangent x. It's the same answer as the last question because nothing has changed. Huh? Am I just reading it wrong? Oh. See. The difference here is it doesn't start on the origin. So we have to include 0 pi. So it's this. It's not like a direct mirror. It's offset as well. Oh, I gotta remember that. Gotta remember that one. That it does not go through the origin. Does not. See? Alright. Use a graph to determine the range of. The range is all real numbers. I hope. Beautiful. Wow, only 11 more questions. This is crazy. I didn't expect to get through this quickly. The first half of the test took me like so many hours. Tan pi over 8 x. Okay, so this is a stretch. A stretch of... And it's getting wider. So I think it's going to be one of these two. So yeah, it looks like instead of pi over 2, so what is that? Like, we're doing pi over 8 times pi? Or pi? Ugh. Pi. Pi over 8. It is 8. So it's going to be, what, 8 wider? So now I'm just getting confused. The period should be 8, right? This doesn't look like 8. It's fit in there. Right? To get the period, this function, we're doing pi divided by pi over 8, which would give us 8. This doesn't seem to show that. In any of these, unless I'm just doing something horribly wrong. But I'm gonna go with my instinct and choose B, and then we'll reassess. Nope. Alright, I'm gonna try it on paper, see if I can. I mean, I guess this seems like it includes more lines. I hate these graphs, dude. Because it looks like they're redrawing the origin at 5 pi, right? And it's impossible to tell. It's impossible to tell if, like, what this 5 pi is referencing. Is it this line? Is it this line? Is it this line? Who knows? It could cover any of these. And it's like, in most questions, yeah, it's the edge of the graph. But if that's true... What is 5 pi equal to? I think yeah, it's got to be that. 5 pi is like over 8. Yeah, it's like double 8. So that would give us 2 8s in the graph, which it checks out. It's got to be that. So, the asymptotes aren't going to be at pi. The asymptotes, I think they're gonna be at 4K. Essentially, it looks like it's half the period, right? Half the period is an asymptote. Yeah, halfway between. Looks like it. I like it. I like that. For the tangent, half the period is the asymptote. That'll work for me. Use the graph to determine the range of y equals. The range is all real numbers. Great. Sweet. 10 more questions. Alright, seeking graphs. This one's supposed to know too. Seeking goes to the origin because it's the inverse cosine. Not the origin, but like it goes through the y-axis because cosine also has its min and max. On the y-axis, allegedly. Okay, so I think once again with this, we don't have to worry about the vertical stretch on this test. So we just got to find our normal secant function looking graph, and I mean, it's probably this one, right? No. Yeah? That's an inversion. I think it's this one. Yeah, because we're flipping it over the x-axis. We'll go with that. Nice. And yeah, so it's like you don't gotta worry about it until you do gotta worry about it, and now it's just all you gotta know is something really esoteric about there's a 16 now, and deal with it. And it doesn't intersect with any line at 16. It's just now you know the graph's bigger than 2. It doesn't seem to change. I guess it does change the range of the function, right? Because if it's times 8, then that means the maximum and minimum of the cosine function or the sine function would be 8. So it is important to think about the amplitude for this. Yes, this does have an amplitude, just not cotangent and tangent. So with this one, I'm thinking the asymptotes are at 0 wherever cosine is at 0, right? I'm thinking it's, I gotta go with this one, right? Because that's the inverse of 2 pi over 1 bow, right? I don't like how I came to that conclusion. Range is... Ugh. Can it just give me 2 sets in a row instead of a set inside of a set? I don't know what that is. Negative 2, -8 bracket. The weird looking union bracket 8 fantastic. I got it. Question number 54. 3 cosecant 3 y equals 3 times cosecant 1 over 8x. So we got what, our amplitude, three. is 2 pi over 1 times 8. Is that right? Yeah, I think so. Is that what 2 divided by 1 divided by 8 is? It's gotta be. Okay, yeah. Cool. So our period is 16. No phase shift, no vertical shift, no flip. Normal sine function just looks like, or cosecant function looks like the sine function, which means it would go through the origin. Which means we should have an asymptote through the origin. The orange gin. In a period of 8. So I find it very difficult to find 0 whenever... Oh, okay, it's the one with the arrow. So there's no asymptote there. Looks like we're kind of out of luck on the whole asymptote on 0 thing. Which is kind of blowing my mind a little bit. Because doesn't the cosecant have an asymptote on 0? Like, there's no phase shift. Zero divided by anything is 0, right? Let's check. Yeah. 0 phase shift. Okay, is there... Okay, this one has an asymptote there, they just didn't draw it. So that's pretty nice of them. And so does this one. They're just like, we don't need to draw those asymptotes. You'll figure it out. So it's A or D. That's great. Thank you. Thank you, Pearson, for trying to ensure that I die from some treatable illness because I can't get a job with healthcare. Alright. It's like, it seems like an exaggeration, but it's like actually accurate. It's so sad. So, this would be the inverse sine function, which would make this D is the correct choice, because this is, sine goes up first, so cosecant should go up first. Fantastic. Love it when I'm right. Knowing things is great. And not knowing things is also great. But in this context, knowing things has literally saved my life. Okay, these got to determine the lane of y equals 3 times cosecant an 8x. K pi. Okay. Look at this. Look. I think it's this. I think the asymptotes are on 8. And 0. I guess 0 is an integer. Integer. Yeah, so it's gotta be B, right? 0 is an integer. Good. It's not an odd integer. It's just an integer. Use the graph to determine the range of y equals 3 CSC. Okay, the range is negative infinity to 8. Sorry, negative infinity to negative, not 8, 3. Wait a minute. Oh, okay. Dude, sometimes the equal sign looks like a negative sign. I thought that I had gotten away with something horrible. Okay, then you got the union, and you got the bracket, you got 3 to infinity, and a close parenthesis. Fantastic. Dude, moving right along. Question number 55. We got cotangent 7x, and there's a vertical shift of -1. So it's looking like we got a period of 7. I guess it's just fair to say anytime there's a fraction here, you just, and the numerator is 1, then 7 pi is the period. So 7 pi. I'm gonna make these tiny graphs a little bigger so we can look at them. I'm not gonna let my cat in. Solve all these problems. What do you gotta say, buddy? The cat talks a lot, but he won't talk with mics in front of him. He's just cool like that, I guess. Alright, so we got a vertical shift -1. That means the origin, the midline, has to be below x-axis, and it looks like that is the case on all of these. Yep. So it's cotangent, which means it's one of these two, because there's no negative shift or reflection. Reflection. That's the word I've been looking for this whole time. Reflection. So it's got to be A or B, because they're both going the normal cotangent way of growing, approaching infinity, approaching positive infinity as x approaches negative asymptote. There we go. That's some math terms thrown together. There he is, the cat. That's really cool and green. Yep. There's the guy. Alright. So we gotta find where the we gotta find how these two are different, right? And it's looks like the main difference is where the asymptotes are. This one goes through the origin. Cotangent is not, right? I believe that's what we've discovered. We can find out. Oh yeah, so we gotta do. Oh my god. Oh yeah, I got it for next. Alright. -1. So it looks like cotangent can have an x value of 0. Okay, we knew that already. Shit. And have a y value of 0. How would we be able to tell? Okay, 7 pi is a period. 0, 7 pi, 14 pi. So periods are on this one. Man, I really think it's B. I think it's B. I don't know how to plug in y values too. Let's try B. Nice. So yeah, okay, it's cotangent can't have a y value of 0. In its normal form. 7 pi k, yeah. We did that in the last problem. And I just already forgot. Ranges. Negative infinity to it's is that -2? Yeah. -2. No, it's just negative infinity to infinity. Yeah. Yeah. It's all of them. Nice. Question number 56. Just gotta check that I didn't miss anything. Nope. Honestly, I was like paranoid about the idea of showing you. It's sort of almost easier. Sorry. Secant function 2 pi over 3 plus 1. So the midline is going to be above the x-axis. Should be the range of, yeah. Okay, so the ranges are all correct, it seems. So this one's like mainly making us try and think about this. Which should just be 3. Let's see. 2 pi over 2 pi over 3 is 3, yeah. So our period is 3. Which means we need this to happen within 3. Secant is in cosine, so very stiff motion. I guess what we're saying here is this first asymptote should have no 1. Oh no. Okay, so it was 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. 0, 2, 4. Okay. I'm just gonna say this one's wrong because this would be the inverse central function. No. This one's wrong. This would be the inverse. Cosine starts above x-axis. This one doesn't start in the right place. On the x-axis. That is this one. This is like the cosecant of what we're trying to do. So I think it's A. Nice. Looks like we gotta sort of, okay, so I'm gonna minimize this graph. It's not really helping. So yeah, I think it's odd integers. It's not a multiple pi. I think it's 3/4. 3/4. 6/4. Yeah, this is 3 over 1. 1, 2, 3, 4. Yeah. Even, odd, even, odd, even. Okay. That's a weird way of doing that, but it works, I guess. Range 0 to, or negative infinity is 0, and then this is 2 to infinity. Comma 0 because of vertical shift. Bracket union, which is cup. I like the name cup better than this one. And then 2 because of the vertical shift. Comma infinity again. Close parentheses. Fantastic. Question number 57. 3 times sine 4x minus 5. Amplitude is 3. Gotta love that. Period and phase shift. Dude, they're just making it easier and easier. Okay, 2 pi over 4, just pi over 2. Very easy. And then phase shift is pi over 4, but it's positive because it's negative in here. Easy. Now you have its graphic. The sine function, starting origin, no reflection, amplitude is 4, period. Power 2. Phase shift. Power 4. Gorgeous. Most beautiful graph I've ever seen. What? Amplitude is 3. Okay. What did I say before? Oh, I saw the 4th. The wumbo. I like calling omega wumbo because it starts with a W looking sign, and then like wumbo means omega. Like wumbo means big, right? And like omega has always been used as a word for big. And I wonder if wumbo, the creation of wumbo, was like based on that thought process. Either way, I think it's fun. Welcome to the study of wombology. If there was a college class in wombology, I would probably take it. Even though I enjoy dealing in minute. Okay. 2. 4. Pi over 2. Alright, amplitude 4. It's a cosine function, so there is an amplitude. Period. 2 pi over 2, so it's just pi. Phase shift. Pi over 2 over 2. Over 1. Which is pi. Negative pi, because it's getting faster. Oh! So I gotta bust the calculator out. Pi over 2 over 2 over 1. That's 2 pi, yes. No. What? That is pi over 4? Yeah. Alright, negative pi over 4. That's fine. Why is that? Let's see. Pi over 2 times, no, divided by 2 over 1. Yeah, flip the, do the inverse, multiply the inverse. Yeah, it's pi over 4. Okay, so it's negative. Nice work. Cosine, starting on the no shift, right? Amplitude is 4. Period. Pi. Phase shift. Negative pi over 4. And no reflection. Good job. Alright, question 59. Find the amplitude. Dude, I feel like the difficulty is sort of petering out a little bit. Maybe it's just because this is the stuff we did most recently, so it's like top of mind still. I expected sort of the asymptote part of secant and cosecant to be more stressful. Amplitude 6. Absolute value of the coefficient of sine. Period is 2 pi over 3. it's negative. I don't know what that means, but I'm gonna try it. Phase shift is to the left. Oh, okay. Ah. I don't need to worry about the negative because it's inside the parenthesis. I can move it outside of the parenthesis because of that identity. Because of that identity, and it's a sign. Well, it's like there's a word for it. I can't remember, but essentially, what it means is your negative in here can just be moved out here for everything but cosine and the inverse of it. I believe that's true. Which just cancels both of them out. I believe. Well, it looks like that's what they're trying to do here. I believe phase shift is negative pi over 6. Shit. I feel like they're trying some like alchemy here. I don't appreciate it. So this does not have to be negative. I think the thing is, I think what they're trying to show me here is that you do this first, and then this has to stay positive. So there we go. Yeah, that's the key. The key to this problem, number 59, is you distribute this negative sign at the very beginning, and then do the rest like normal. But it's like, this is what they're trying to show you, is that, yeah, we know it's there, but you just have to get rid of it before you can do the period, amplitude, phase shift, etc., etc. And then when we graph it, it's just going to be a normal sine function without the negative because they're canceling each other out. Or, that's what I think. We're about to find out if that holds true. But I don't see why it wouldn't, you know. Ah. This negative canceled out this negative here too. Very interesting. It's weird because they're saying W must be positive, right? But you're still using it in factoring your calculation of the phase shifts. You're still using the negative attached to it. So I don't like the way that they worded that. I feel like not a super like intuitive thing here. But that'll be a good question. Either way, now we know what to do, which it seems to be distribute this first, but then use it anyway when you're calculating your phase shift. I don't know, it seems sus. This is kind of sus. This question's sus. But whatever. Just make a note of that. Write the equation of a sine function as the following characteristics. Assume that there is no vertical shift. Okay, that's fine. Okay, so sine function. We got y equals 3 sine blank x minus, so we need 7 pi has to be equal to 2 pi over w, wumbo, omega, and one sixth has to be equal to b over omega. Am I missing something? Yeah, no, I'm not. So I think this is they got like a fire alarm, like a fire drill in the background of this lo-fi song right now, and it's kind of fucking with my head a little bit. It's like weirdly nostalgic. I let my cat out. It's like, all right. So 7 pi divided by what equals 2 pi. Is it 14? Yeah, okay, it's 14 over 2. 14 over 4? Seems weird. So it's 2 pi. Okay, yeah, 14 over 4. Which is 7 over 2. So that would mean 2 pi divided by 7 over 2. Shit. No, 2 pi. Divided by 7 pi. That'd give me 7, 2. That's not right, it's 2 over 7. So I believe our wumbo has to be 2/7. Yep. Wombo is 2/7. X minus. So now we need to find how to make 1/6 times 2/7 equals what? I really should not be using Desmos for this because, like, this app is too broken. It's like too overpowered. It makes like being able to see the multiple numbers at once in a calculator is so much easier. 1/6. No. Our phase shift has to be one over 21, which is our P, divided by 2/7 is our W, which gives us 1/6. Yeah. Cool. So it should be P is minus 121. 1/21st. Oh, it's disgusting. It's just like a horrible thing to say. Sometimes the English language just makes me nauseous. I'm a native speaker of English. I don't speak any other languages, but it's like I can still tell like that's bullshit. 1/21st or 1/21th. I have no idea which one's right, but I think it's the second one, and it's like disgusting. Let's check. One 21st. This guy meant to say unironically, because I would say 1/21 unironically, or ironically means you would purposely say it wrong for the fun of it. Unless that could be his meaning. I don't know. I need to get off Reddit. Alright. Nice work. Thanks. So yeah, it's 1/21st, which sounds more wrong, but we'll take it. Alright. So we're just doing the same thing once again. And it's another sine function. So they're not even going to try and challenge us. Y equals 4 sine blank x plus, because there's a negative phase shift, blank. So I'm going to start with the period because we know 2 of the 3 variables. 6 pi equals wombo 2 pi over wombo. 2 divided by what? So I believe it's a third. Nope. It's just 3. Nope. Oh, I think it's a third. And that's what 6 pi looks like. Yep. So, wombo omega is a third. I'm going to stop memeing for 1 second. So now we have omega of a ninth has to equal 3. Is same way? Is 3 over phi? Is that how that happens? Let's find out. I just don't like the way that looks. I'd rather just do it the normal way. Okay. I'm sorry, is that this? Yeah, I guess so. So it's 3 times what equals a 9. I'm like confusing myself a little bit here. So it's 1/9 divided by 3. Is that it? $127. So let's reverse engineer that. 127 divided by 1/3. Yep, that works. That makes our equation 4 sine y equals 4 sine 1/3 x plus, because the phase shift is negative, 1/27. Not 72nd, 27. That was fun. I do like these. Nice work. Wow. Do the dopamines on today. Alright. Function below models the average monthly temperature T. Okay. Our Jesus. Our X is the month. Okay. There's only 12 possibilities. Ooh, this one's like this one's trippy, man. I guess there could be 24 months. Like, this last part's just like trying to throw us off here. Okay, highest average monthly temperature is simply amplitude plus vertical shift. Amplitude 21.55 plus. This is easy though. I believe. We're about to find out. This C part is going to be, I think, the where they decide to mess with this. Dang, that is. What city is this, bro? I don't live there. Oh wait, nope, that gets fucking cold. Holy shit! What city is this? It's like Nova Scotia. Are we using a Canadian textbook? So that's the lowest possible temperature, and that's just the absolute minimum 32.1, which is just amplitude minus oh, we need the negative amplitude though, right? No. It's the vertical shift minus the amplitude. Pretty sure. That's the same thing. Somehow. Oh, good. Yeah. Okay. I don't know how that works, but we'll figure it out. The time between the highest and lowest average temperatures is what, half the period? It can't be the phase shift, right? Phase shift is like what month it starts, right? So it's just got to be half the period. Let's find the period. This is just 2 pi over 6. I think for complex stuff like this, pi with it. I'm pretty sure that this works. And then you add pi at the end. No, because then you still have to factor out pi. That's the important part. So let's just try 2 pi over 6. I think it's 12. 12. So 6 is the answer. Excellent. Dude, no way we're done with this thing. That's crazy. 100%? Jesus. I don't have to do redo any of these 62 questions. That's crazy. My god. Okay, so 59. This is the one that I think is just like unintuitive. That we really just maybe we covered it in class and I wasn't paying attention. Or maybe we didn't cover it in class and it's just this small detail of like I realize we're dividing pi over 2 by -3, but we don't use that same method to find the period. So I'm just gonna take a picture. That's just an order of operation question, but we made it, and you know, I had a great time. Only took 3 hours to do 30 questions, so not the worst experience of my life. Yeah, if you end up doing this content and it serves you well, that makes me happy. I'm just happy to be able to film it. It gives me a little extra motivation to study and puts the pressure on for like forcing myself to think clearly, because truthfully doing 62 problems is a wee bit mind-numbing. But yeah, good luck on the test, everyone. I'm gonna try and do one more of these before the test, where it's the review of the regular Canvas thing, the review that he made. That's supposed to be like very similar to the test itself. But I'm not doing that tonight because I just simply do not feel like it. But yeah, I hope this tutorial. Like, I don't know if I would watch something like this, but I might. You know, I might. Hard to say truly, but I think the live streaming experience would be fun. Like, I would watch it while it was live, maybe. Yeah, I think so. Because live, I feel like the beauty of live is you can ask about things you don't understand. which sort of loses luster after the video. But if you do have any questions about anything that I did, or if you saw anything that I did wrong, go ahead and just, there's a comment section below. You can roast me there, or you can ask questions there, and I'll get around to them. All right, thank you. Stream is over. See ya.